Hello, and today's purpose of the day is I can factor binomials that are the difference of squares and special products. Let's take a look at the warm-up. Multiply x plus 9 times x minus 9. Well, if you remember, we here could FOIL, or this is going to give us a special product, right? It's the product of a sum and difference, so I can square my first term, get x squared, and then my middle terms will cancel out, and my last term will be 9 times negative 9, which is negative 81. Same thing below, b squared minus 2 times the quantity b squared plus 2. This is a product of a sum and difference. So I'll square my first term and get b to the fourth, and then negative 2 times 2 is negative 4, and my middle terms cancel out. So that leads us here to the difference of two squares. So we know when we FOIL or multiply binomials a plus b and a minus b, we end up getting a squared minus b squared. Or if we could flip-flop those and have a minus b times a plus b, we get a squared minus b squared. So now we are going to start with the end example, x squared minus 25, and we're going to work backwards. So we're going to start with the end results, and work backwards. So we know, like a squared minus b squared, again, we take the square root of our first term, a squared and get a, square root of b squared and get b, and then we just have one binomial that has a plus and one binomial that has a minus. So if we factor this, we know the square root of x squared is x, so that goes in the first spot of each binomial. The square root of 25 is 5, and one will be a plus and one will be a minus. So we just factor x squared minus 25 very quickly without really showing any work. So let's take a look at a few more examples. 16h squared minus 9a squared, and it only works to factor these when, again, I have a subtraction sign in between these two binomials. This is the quick way to factor. So we take the square root of 16h squared and get 4h, and that goes in the first spot of each binomial. And the square root of 9a squared is 3a, and then one is a plus sign, one is a minus sign, and that would be my answer. Okay, let's look at another example, and again, we want to try to do these in our head and get quick at factoring these. So 121 minus 4b squared, if I take the square root of my first term, I get 11. Square root of my last term, I get 2b, and then we have one that's a plus and one that's a minus. So it's really not very difficult to factor these, you just got to get the pattern down. Okay, let's look at number 3. Okay, so I look at 27g cubed and 3g. Well, we can't take the square root of our first term, and we can't take the square root of our last term like we could in the other examples, right? And we had the difference of squares, and I didn't say what that was there, but that's called the difference of two squares, right? Because we can take the square root of our first term and square root of our last term, and then difference means subtraction, so that's the difference of two squares. But now, this is not the difference of two squares, because 27 you can't take the square root of, and 3 you can't take the square root of. But what can we take out of both of them? Well, we can take out a GCF, and that GCF is 3g, and if I undistribute, I get 9g squared minus 1. Again, if I'm at 3g, how do I get to 27g cubed times 9g squared? If I'm at 3g, how do I get to negative 3g? Well, a negative 1. And now, let's look at continue to factor again. So I'm going to continue to factor this 9g squared minus 1 because now we see a difference of squares, right? We can take the square root of 9g squared and we can take the square root of negative 1. A lot of times students forget that we can take the square root of 1, but the square root of 1 is just 1. So I have 3g in my answer, and now I'm going to break down 9g squared minus 1, and the square root of 9g is 3g. Square root of 1 is 1. And then one's a plus, one's a minus, and now that's the fully factored form of 27g cubed minus 3g. And you can always check your work by FOILing and going back and multiplying all the products that you got and make sure you get your original problem. Let's look at a few more examples. Now we may need to apply the technique more than once, so let's zoom in. So if we look at number 1, b to the fourth minus 16. I can, this is the difference of squares, right? I can take the square root of b to the fourth, and I can take the square root of 16. So if I write this down, the square root of b to the fourth is b squared. Square root of 16 is 4. And then one's a plus, one's a minus. But now, applying the technique more than once means this b squared minus 4 is also the difference of squares, right? That's also the difference of squares. And so I could break that down into the square root of b squared is b, square root of 4 is 2, and one's a plus and one's a minus. Now, why did I not break down b squared plus 4? Well, if we tried breaking that down into b plus 2 and b plus 2, right, because there's a plus sign, so you might be thinking, oh, well, what if we just put plus signs right in both binomials? Well, let's FOIL this and let's see what we get. B times b is b squared plus 2b plus another 2b plus 4. So we get b squared plus 4b plus 4, which is not b squared plus 4, right? We get that middle term. So it doesn't work out. And again, it's only the difference of two squares, not the sum of two squares. So now to write my final answer, I have to still write the b squared plus 4 because that's part of my answer along with b plus 2 and b minus 2. So that would be the fully factored form. You always have to look and see, is my answer fully factored or in the completely simplified form? And if it's not, then you need to continue to factor. So be looking for some more things to factor down. Let's look at number 2, 625 minus x to the 4th. So this is a difference of two squares, in that I can take the square root of 625, and that's 25. And then the square root of x to the 4th, which is x squared. And then one's a minus, one's a plus. And then again, be on the lookout. Here's another difference of two squares. So if I factor this again, square root of 25 is 5. Square root of x squared is x. And then one's a plus, one's a minus. And then I also can't forget to bring the 25 plus x squared into my final answer because that is still in my answer. All right, now let's look at applying different techniques. So some techniques that we already know about. Excuse me. So if I look at 5x to the 5th minus 45x, those are not the difference of two squares, but what can I take out of both of them? I can take out a 5x, and I'm going to zoom in a little bit. A 5x. So here I go, I take out a 5x. Now I undistribute, and 5 times what gives me 5x to the 5th? X to the 4th. 5x times what gives me negative 45x? Well, a negative 9. Now I look and see if I can continue to factor. And this x squared, or x to the 4th minus 9, is a difference of squares, so I can continue to factor that. So 5x is in my answer. And I can break down x to the 4th minus 9, take the square root of both terms, and get x squared in my first spot of the binomial, and square root of 9 is 3 in the second spot. And one's a plus and one's a minus. Again, don't forget, if you want to check your work, go back and FOIL and make sure and multiply all the terms that you get what you originally started with. Okay, number 2 says 7x cubed plus 21x squared minus 7x minus 21. So we see 4 terms here. Do you remember what method to use to factor when you see 4 terms? You got it, factor by grouping. So we first look at the terms and we see, should we regroup these terms at all? And I think we should. I think we should put the 7x cubed by the negative 7x and then the 21x squared by the negative 21. So let's go ahead and do that. So I have 7x cubed minus 7x plus 21x squared minus 21. Now I'm going to group these into groups of 2. And let's take out the GCF of 7x cubed minus 7x. Well, that's a 7x. Now if I undistribute, 7x times what gives me 7x cubed? X squared. And then 7x times what gives me negative 7x? A minus 1. Now let's look at our 21x squared minus 21 and take out the GCF. That would be 21. And now 21 to get to 21x squared would be an x squared. 21 times what gives me negative 21? A negative 1. So we see the same factor written twice. That's good if you can recall factor by grouping. And so we write our answer by putting our two factors outside the parentheses together. And then in our other parentheses goes x squared minus 1. And now we can continue to factor actually both of these terms. So originally when I started factor by grouping, I probably could have taken a 7 out right away, but I can always take that out at the end. So with this 7x and 21, I can take out a 7 and then get x plus 3. With this x squared minus 1, what do we call that? Well, we just looked at some examples like that, and that's the difference of squares, because I can take the square root of x squared and the square root of 1. Can't forget about 1. Square root of 1 is 1. So that factors into two binomials that are almost the same, and the square root of x squared is x, square root of 1 is 1, and 1's a plus, and 1's a minus. So this had a lot of steps to solve for the final answer, and this was again a factor by grouping example that had a lot of techniques within it. Let's look at number 3. One more example here. So I look at these terms and I first ask myself if I want to regroup. And I don't want to regroup them. They're already good the way they are because I can take out a GCF of each of the two terms. And the GCF of 2m cubed plus m squared would be an m squared. M squared times what gives me 2m cubed? Times a 2m. And m squared times what gives me an m squared? Plus 1. And now the GCF of negative 50m and minus 25, I'll take out a 25. And then 25 times what gives me negative 50m? A negative 2m. And 25 times what gives me negative 25? A minus 1. So I see these two factors are almost the same. They just differ by a factor of negative 1, which, what do we call that again? You got it, an additive inverse. So I'm going to take out a negative 1 here, bring it to this 25, so that becomes negative 25. This negative 2m becomes positive. The negative 1 becomes positive. And then I write my final answer by putting my two factors outside the parentheses together. An m squared plus or minus 25 now, right? I change that. And then a 2m plus 1. And now I continue looking at this m squared minus 25, and that can continue to be factored. So I can take the square root of m squared and get m, square root of 25 and get 5, and then 1's a plus, 1's a minus, and I can't forget to attach on my 2m plus 1. And then that would be my final answer to that third example. Thanks for listening to the video on factoring binomials that are the difference of squares and special products. Have a great day. Bye-bye.